Hello, we are over I-143. I'm Delcy, and there are also Malik and Falarin here. And today we are honored to present our final project for the system modeling course, which we have analyzed and developed an optimization model for NFC's log allocation system, which is to maximize daily profit while meeting market demands and operational constraints. So we hope this presentation gives a clear explanation, and let us begin to the presentation.
Okay, so first I'm going to talk about problem situation. So in the problem situation sections, we divide the problem situation into several aspects, namely process, structure, conflict, uncertainties, actions and reactions, controls, goals and aims, worldview, people, relationships, resources, and consequences. And you can see the detail of the descriptions of this aspect in the table of the screens. I'm not going to mention it. Next. Next. Okay, so here is the rich picture diagram and the hierarchy diagram. So the rich picture diagram shows the flow starting from the forest, F1 and F2, and logs are harvested and undergo quality inspections to determine their price and sustainability. And after inspections, logs are allocated to three destinations: directly exported, sent to the sawmill, and or sent to the pulp mill. And the sawmill process logs into construction timber and dressed timber with capacity and cost constraints. And finished products are stored in inventory before being sold in timber and pulp markets. And for hierarchy diagram, um, at the core, System 1 focuses on the daily log allocation decision to maximize net profit and considering production's capacities, cost, on market demand. And then System 2 expands to the overall NFC productions and distribution system. And System 3 represents um, the external environment covering market prices, regulations, and which all influences NFC strategies and operational decisions.
Okay, so in this section, I will briefly present the stakeholder analysis. The first one is the problem owner is the NFC management. They, as the main decision makers, they aim to maximize daily profits by efficiently allocating logs to sawmills, pulp mills, and experts. The second one is the problem customer. So they expect the high quality products delivered in stable quantities. And the third one is problem user. They are responsible for implementing log allocation and ensuring smooth operations. And they are the NFC operational team, so including a production schedulers, sawmill and pulp mills supervisors, and the logistic units. And lastly, the problem analyst, which are our team, me, Malik, and Falarin from Evera 143. So we are in charge of collecting the data, developing optimization models, and evaluating various scenarios. Okay, so now let's move to the six problem elements. The first one is the decision maker. It's still at the NFC management, so they are responsible for making strategic decisions about how logs are distributed across operations. Second one is the objective, which is to maximize income while taking into account product demand, operational costs, and selling prices. The third one is decision criteria, like the sawmill capacity of 6 hours per day, minimum demand for construction timber of 32 meter cubic per day, and so on, as you can see on the slide. And next is the performance measures. There are three: the total net profit produced per day, the utilization levels of the sawmill and pulp mill, and the fulfillment of demand for both pulp and timber. And then there are also the control inputs or alternatives, which are the choices in how logs from first F1 and F2 are allocated. And finally, the context of the system that includes the global wood and pulp market, export regulations, and resource limitation like logistics and production capacities.
All right, next up, I would like to explain the influence diagram. Basically, it all starts from the logs from Forest 1 and Forest 2. The logs from Forest 1 and Forest 2 affects to, first off, the total logs harvesting cost, which is affected by the logs from F1 to and the cost of harvesting logs from each forest. And then next, we can continue to the total construction timber, which is affected from the amount of logs from F1 and F2, and the times the suitable amount of logs to be uh allocated to either the exported or the sawmill. And from that we can, and there's also a percentage of how much uh each um each type of timber and scrap wood from each forest are produced. So for example, there's uh over here we can see that there's an F1 construction timber conversion, F2 constructed timber conversion, and so on for dress timber and scrap. The scrap wood gets transported into the pulp mill, same as combined with the unsuitable logs from forest one and forest two. While also there are logs that with the some logs that are suitable are also exported, are to be exported. Now, producing timber and pulp, and also exporting logs, they all have their own costs. For example, total timber cost here. There's transportation cost, which is this transportation from forest one and forest two to the sawmill, and then the processing cost for construction timber, and also processing cost for the dress timber. Now, for the pulp mill, there are um, a few factors. For example, here there's forest two and forest one to pulp mill cost, and there's also the scrap wood, which use the sawmill to pulp mill cost, and also a processing cost. For the exported logs, the costs are uh, the forest one to the port to be exported cost, which is from forest one and forest two. Now, for the value, um, it's exported value times total exported value. For the pulp, total pulp value, it's pulp value times total pulp. Total timber value is all of the timbers times the timber value of each type of timber. For example, construction timber value and dressing timber value, they all get total and plus into one, which gives us which gives us the total value of all of the um of each product. For example, there's the total timber value combined with the total exported value and also total pulp value, while the total cost is from all of the costs from making each product. For example, the total timber cost, the total export cost, the total pulp cost, and combined with the total logs harvesting cost, because back at the beginning there was a harvesting cost and also some fixed costs, which are the sawmill, the pulp mill, and administrative overhead fixed costs. And combining that, we get the total amount of profit. Next. Now from here we can see the total amount of costs, which is 32,863 euros, and the total value of all of the timbers. And we can see here the total allocation for each logs from F1 and F2 and where they all wed. So for example, here there's 17 logs for dress timber, 33 logs for construction timber, and 102 logs gets exported, and a total of 84 tons of pulps get turned into pulp. And the profit here, we can see that the total value here is 59,000 minus the total cost, which is 32,000. For more in-depth counting, we can see it in our full report. All right, next. All right. In conclusion, um, NFC has set up such a in conclusion, based on our group's mathematical result to maximize profit with all the constraints, NFC has set up such by allocating 16 logs from Forest 1 to become dress timber, 31 to become construction timber, 0 to be exported, and 76 to become pulp. And Forest 2, two of them to become dress timber, 1 becomes construction timber, and 102 to be exported, and 86 to be turned into pulp. By doing this, NFC has fulfilled the constraints of having a minimum of 32 constrained timber, a maximum of 42 dress timber, and demand which needs to be a minimum of 60 tons and a maximum of 160 tons, and fulfills the sawmill capacity hours. By doing this, NFC makes an earning of 26,209 euros. And all right, next.
Okay, so that concludes our presentation for today. Once again, we are Everai 143. We'd like to thank you for taking the time to watch our presentation, and we appreciate your attention. Thank you very much.